Good morning. And that noise behind me is a 52mm high feed cutter taking 1mm a pass off a 60mm piece of plate. Today we're talking about billet manifolds, how we build them and how amazing they are. Right, so we've just seen that first step in the CNC machine, and that was a 60mm piece of plate that's pre-flame cut, that's been surfaced off and turned into this, and this is basically the very first step. And as you can see, the sides have also been machined to make it parallel, so we've got somewhere good, clean and straight to grip onto. So that's step number one. Step number two is this here, and you can sort of see it's starting to look like a bit of a manifold, and this is the rear profile. Now this one's quite nice, and we haven't shown you this one before. So this has got the Turbo Smart 40mm wastegate flange built in, which is really, really nice. This is a Gen 5 Turbo Smart 40mm comp gate. This is the high pressure version, so 30 psi is what we're set at from the factory. And the whole point of what you can see here is to reduce the need to have two wastegates on a twin scroll setup, because you've all seen probably Skyline Supras and big power cars like that that have two sets of wastegates for your twin scroll manifolds, and it is just a mass of like pipes and mess, and it just fills the engine bay. And in some cases it looks cool, and in some cases it looks like just way too much filling the engine bay, too much complication. Anyway, so this is the idea we've come up with. So basically this little division helps to divide the wastegate, the gases that are going to go to the wastegate, nearly all the way up to the actual valve itself, the valve seat. Okay, so this is about as good as it gets to get a nice divided section right up to your wastegate, and that's how we use one wastegate on a twin scroll setup. So that's step two, and that, as you can see on the back, is still just a flat plate. There's no inner profile of that at all. And then step three is this. So this is sort of has been through that process, and then it's been flipped, and these are your internal profiles. And you can see here you've got really nice radiuses which match the 606 port. So you can see how the gasket nicely matches the port profile of that, and that is where we're gaining a lot of the performance over the other manifolds out there. We don't have to press cones. We don't have to die grind flanges at an angle. We're not having to get a CNC'd flange that, you know, in a space of 20mm really ramps in. You know, none of that has to happen. With this, it's just a really nice, gentle transition, which is awesome for gas flow, as you can see. You know, that there's no sharp path or whatever. You can see the two positions here, which is where the dowels go. And these two halves, when that one's machined like this one, will locate together, and then I will weld this all the way around. Inside the ports here, you can see there's a nice big chamfer all the way around, so I can put a nice good root pass in there, and then multiple other passes just to make that a really nice strong weld, so that it all stays rigid. And then once that's welded together, obviously it all locates nicely. It'll get stood up, and then this top profile will be machined, so it'll kind of look a little bit like this sort of gasket shape. Obviously this is a 5-cylinder gasket that picks up, this is a 6-cylinder manifold, but it will have that nice kind of wavy shape in it with all the holes. But that's the last bit after I've welded it. Hello. Yeah. So now I'm the cameraman.
This is the 3D model, 6-port manifold. And as you can see, this has got it in. Now this hasn't got the flange on. Let's put that back on. Cool. So that's obviously the flange shape that we're going on, so it looks nearer to the gasket.
Yeah. Oh yeah, that's good. Yeah.
Yep. All this side here will be machined after welding, so it's all, so you get a perfect seal.
So what about the cutaway? Let's see the throat area cutaway where the wastegate lives, because that really shows some of the detail that goes into that. Yeah, that's good.
So as you can see here.
Yeah. Yes. So this sorry to interrupt. This is like your technical bit, but this bit is really crucial. So where the transition, where it goes from being horizontal to the gas flow kind of being vertical, the taper that leads up, the contour that leads up, is literally as gentle as we can get it. It actually leads into the upper part, so both the top section and the bottom section join together in this taper, which is really important. And you can see there the path, how it takes a little bit of gas out of each side down to the wastegate, which is pretty cool. You can obviously see that on there. You can see the wastegate flange is even machined in direct. Anyway, tell us something technical about that.
So with the ports in the manifold, the port is either equal to or more than the exhaust ports coming out of the engine casting. So we have zero restriction in the manifold.
Yeah, that's going to give us some nice gains. That is good.
So if we look at the other cutaway now, so if we look at we find the right one, there we go. You can see there how we've got a nice radius coming in. Yeah, and obviously that radius would look more natural if the wastegate port wasn't there. We do versions without the wastegate port. You can see it there.
Yeah, that's also important to note, that the inside of this, it actually has a nice shape leading into the wastegate. It isn't just a rough cut hole that goes down. That's also very nice and smooth. So it's all got gas flow related. Nice. And then hypermill, obviously you optimise that to get the speed of the whole process up.
We did. So this is the parts that have just been done. As you can see, it's a lot of yellow and red lines at the moment.
Yeah.
So if we turn some of them off so we can actually see it all. So first of all, look at his roughing passes. So this is taking like 2 mil depth of cut and getting some material out just as fast as possible, basically. So that's just getting all the meat out. But that leaves you with a really jagged edge. It doesn't give you any smoothing at all.
Like steps?
Yeah, basically.
And what cutter did you use?
So we used a WNT XD KT using a 0.8 radius insert.
Okay.
We then go on to finish machining. So as you can see now, it's going down the walls at very small cuts but extremely high feed rates, and that's what gets us the smoothness of the parts.
And what tool was that?
Again, another XDKT, but the inserts now had a radius on it to create a bullnose tool.
Ah, right, okay, just a larger radius.
Yeah, so 2.5 radius on this.
Oh, wow.
So that gets us a real nice blend.
Did you have to modify the tool body to make that fit?
I did. I did. Yeah. And then finally, because it's a 16 mil tool, it can't get into all the little nooks and crannies. So we're going with a little 12, and the 12 mil ball nose takes out all the bits that the 16 can't get to. But rather than wasting all its time going around everything again, it only goes in and gets the bits that the 16's missed.
Yeah, perfect.
So it's all about just getting some efficiency out of the tool path as much as possible.
Nice. Right, well, what I'll do in the next part of the video is show a little bit of that. We'll clean the screen on the machine and then show it doing a little bit of those passes. This cutter is doing the final finishing pass. You can see, if you zoom in on a step section, the initial roughing pass, which is the first steps that we showed on Hypermill, and then this is actually just completing it and making them really smooth, which is nice. Normally this would be running coolant and it'd be squirting everywhere, but for the purposes of this video, we're not. So that you can see the amazing things that are going on, even though it doesn't look like a lot's going on. We're on to the next phase now. Jonathan has presented me with 2 of his nicely machined pieces, which is great. And they've all been oiled up so that they don't corrode or kind of get any surface rust overnight. So what I've got to do is, I'm just taking a little bit of thinner and I'm just going to wipe these all down just to get them absolutely clean so that there's no traces of oil ready for me to weld. So as you can see, I've got 2 perfect halves. They have dowel pin positions. I just have to pop the dowel pin in, but I like to give it a wipe out first. Look how nice they look. Look at that with its wastegate. You can see. And these are unique But there is a difference between this manifold and other billet manifolds out there, and quite a big one. This is being done just out of 2 halves. A lot of other manifolds you'll see, it'll be a separate flange on there and be a separate flange on there, all sorts of separate parts, where this isn't. This is actually just 2 sections, and it's quite rare to see that. It's very rare, in fact. I don't think I've even seen one other. You can see the wastegate ports, how nicely formed they are, and they even have a nice beveled edge, and then a nice ramp that leads up into the port as that comes round, so all super smooth. It's quite awesome. That's the last time it's going to be seen before I weld it. And you can see here, you see how we've left a nice weld prep, well, it's machined in, so that we've got a really deep groove. So that weld, you know, you're talking sort of 5-6 mil of fillet in the manifold, even flush. So, you know, get that as super strong as possible, and that goes all the way around the back, and it actually goes even into the ports themselves just by a few mil. And I actually put the welder in there and TIG weld right down the actual ports to get them connected together. Right, I'm going to continue cleaning this up, and then I'll do a little bit of video of the actual welding process. Have fun. Just applying a few tacks all the way around the manifold so that we can take off the clamps, and then that'll allow me to be able to get much more movement and more comfort as I'm trying to weld it along the main passes. But it's coming out pretty nice. Just adding a tiny bit of filler rod. This is the initial pack, so we need a decent bit of heat. Take your time and try not to burn the sidewall. I'm just running out of hand travel there, where I've got my hand rested, so I'm going to have to stop and move along. I'm going over the original top a little bit. I'm not going to take it to the full length. There we go. So the final op, which is making it flange shaped, and you can see we've just started, and this is obviously where it's been welded together. Some spot marks have been done for the holes, everything's being clocked up, and yeah, take her away. It sounds good. It sounds like it's doing a lot. Do you like this process?
I do. So yeah, it's a spigot process. So it goes round and nibbles out the bits it needs to, so we're not wasting time cutting any fresh air.
I like this process because it's the last one. And these are epic. Lots and lots and lots of machining work. All to bring you guys the best manifolds for your OM606 or 605. Right, so this is the finished product. And what have we got? We've got T3, T4, and they're both wastegated versions. So we have the beautiful wastegate port in there. And as you can see, they're dated with the model. So this is a T4, 6-cylinder wastegate. But you can also see the flange is now fully finished. So you've got all the original shape put back in, a bit like the standard gasket, and all the inner profiles are chamfered. You can see where it's all been welded, and I'm really proud of the result. It is a really fantastic finished product. So, and also one of the more interesting points is we have done a weight comparison, because somebody mentioned about the, sorry for the noise in the background, the CNC machine's busy, of course. We did a back-to-back weight comparison of a billet manifold versus the tubular, because as soon as we put a photo of this on, obviously people can't help but say negative stuff, and someone straight away was like, I bet it weighs a ton. Well, actually, let's weigh it and find out. Let's see. We'll do T4 versus T4. Let's find out. Scales are zeroed, as you can see. 12 kilos for the billet manifold. Yeah. Take the billet manifold off. Fabricated manifold. 12 kilos. So they are identical. Both are T4s. Let's put them both on together. 24. Both T4. The only difference is this one doesn't have a wastegate outlet. So normally if we wanted to have a wastegate in this one, we'd have to weld an extra piece in here. So there would be actually a little bit more weight. I mean, it'd be negligible, but it would be a little bit more weight. But you can see the obvious benefit between these two manifolds here. These both obviously bolt onto the very same flange. Look at the distinct advantage for room that you get. There is so much more available space in your engine bay simply by having this design over this. The other obvious benefit is when we have the CNC'd manifold like this, you know, we have to have this really sharp immediate transition, which on the 606 the exhaust ports, our outlets are here and here. So we're running instantly into a brick wall, and that is literally the case with all tubular manifold designs. Some are worse than others. Some have a very thin flange and immediately going at an angle, and they are really terrible for flow. That being one of the most restrictive points on a 606 build manifold, we addressed that, and that's why you look inside the ports of this newest design, and I know I've mentioned it before, but they literally are the full width. So when those exhaust gases flow, they are not restricted by anything. They're directly into the port and then on their way to where they need to be. And lots of care has gone into the flow dynamics of this, so that every curve, every corner doesn't have any kind of a back eddy effect, and everything has a really nice gentle flow. And from the first one of these to this one, we've even modified the ramp angle in here, because obviously the real only corner that these have to, that the gas has to travel around, is obviously from the horizontal to the vertical, horizontal coming out the engine to vertical going into the turbo. So we've made a massive, like the transition in there is huge. It literally starts right back here and ramps all the way up into the port in a really nice way. And you can see that. This one comes up from this angle like this, and then this port comes up from this angle like this, because obviously they're coming from two different directions. And you can see into the wastegate there as well, all divided. So weight comparison were the same. Space in the engine bay, this is 10 times better. This will fit in much more applications than this. We only have to have one design of this for 6 different tubular manifold designs. So that is a huge advantage. So there you go, the finished product versus our previous product. This is gold ceramic coated. This is obviously worth mentioning as well. You can have any of these ceramic coated if you choose. Drop down on the website. So if you want to get a gold ceramic coat, if you want any kind of ceramic coating, no problem. If not, the manifold will be supplied in raw metal, oiled in a bag. So you need to protect this, otherwise it will rust. It's steel at the end of the day. So it's up to you. You can either spray it with VHT, or you can ceramic coat it, or we can do it for you. Anyway, hope you've enjoyed the video. I've enjoyed making it. I've really enjoyed making these, and I think we're going to see these on a lot of OM606s soon.